Okay, everyone, let's try a couple more questions. So we're going to do these ones. They're applying straight line straight line graphs to real life situations. So I would expect that you are going to pause this, try these questions, and then see how you went. So pause the questions, read them, give them a go. Okay, so I'm assuming you've tried it. I'm going to have a look at the answer to question 2. Sylvia and Amy work at a hot dog stall at the football. The graph shows the different amounts in dollars they earn for working 8 hours. Question A, Amy earns $10 an hour. Which graph shows the amount Amy earns? So let's have a look at the picture. Okay, if I was to go across for 1 hour, this first graph shows it's earning $10 for the hour. So that must be the graph that Amy is using is the graph 2. So we can even call that now Amy if we want. Okay, so we're right. The answer to A is graph 2. B, write a formula H and A that shows the amount Amy earns in H hours. Okay, so how much she earns they're calling that A. And for every hour she worked, so that's what H stands for, 1 hour, 2 hours, 3 hours, or whatever. So if she works 1 hour, she gets $10. If she works $2, she gets $20. So every hour she works gets times by 10. So you can write that as 10H, or H times 10. What about Sylvia? How much does she earn per hour? Well, that must be the other graph. So let's have a look here. What happens when we go across 1 hour up till we hit the other graph across here? What amount is that? That's between 10 and 20. Halfway between 10 and 20, that must be 15. So that's the amount that Sylvia's earning per hour. So we could call this graph, here, graph 1, we could call that Sylvia's graph. So the answer to C, how much does Sylvia earn per hour? She earns $15 per hour. Question D, use the graph to calculate how much more Sylvia earns than Amy when they both work 4 hours. Well, let's have a look here. Let's use a different pen color. Let's do Sylvia in orange. So at 4 hours, here we go. How much is she earning? I've got to keep going up until I hit Sylvia's graph. Okay, I hit the line, I go across to here. She's earning $60 an hour. Okay, well, let's have a look at what Amy, let's call her, do the green one. Also at 4 hours. Okay, we've got to go up here. We just have to hit until we hit Amy's graph. Go across. What's she earning? $40. So how much more does Sylvia earn than Amy? To do that one. How much more? Sylvia earns $60. Amy earns $40. How much more? 60 minus 40 gives us $20. Okay, let's have a look at question 3, which I'm assuming you've also tried. You've paused and given it a go. Graham likes to jump out of planes. This graph shows his height h in meters above the ground t seconds after he opened the parachute. So we can see they've even given us some points on there, but we're starting here at 0 in time and we're going across there in seconds. Okay, copy this table and use the graph to help you fill out the missing values. So when we are at 0, looking here on the graph, let's use a different color, make it easier to see. When we're looking at the graph here at 0, where is Graham actually located? We don't go until we hit the graph. He is 1,000 meters off the ground. So on that thing here, we need to put 1,000 in our table. What about 20 seconds? Okay, here we are at 20 seconds. How high is he? We need to go there. It's 800. So we need to go, he is 800 meters above the ground at 20. At 40, okay, over there, that's at 600 meters. 60 seconds, I should say. At 60 seconds in time, we're now up to 400 meters. And then we keep going. The last 80 up there, across there is 200, and then 100, he's down to ground level. So we can fill that in. 80, what did I say it was? I've forgotten already. It was 200. And after 100 seconds, he's actually on the ground. So it's 0 meters. How high was he when he opened his parachute? Well, we saw that. That was at the very beginning. Up here, that's 1,000. And the answer to B is 1,000 meters high. You've got to have the units, okay? Have to say how many meters it was or whatever units you're talking in. How many seconds after he's opened his parachute did he land? Okay, well, he landed here when he's finally on the ground. This is when he landed. So how many seconds from there to there? It's 100 seconds. You can see that in the graph. So we'll go down here and we can say 100 seconds. Okay, question D. How fast was he falling when his parachute opened? Oh, that's a question. Good, interesting question. How fast was he falling when his parachute opened? So this is over time. How quickly is he falling? So this is a trickier question, and we have done speed is equal to distance over time when we did rates. You might have forgotten that one. So we can work that out by how far did he fall? He fell 1,000 meters. So that's the distance. And how long did it take? That's the time. That's 100 seconds. Okay, so we can write that in our formula. Oops. Let's write that down here. So we are going to do speed is equal to distance over time. The distance he traveled was 1,000 meters, and the time it took was 100 seconds. So the speed he was traveling at is 1,000 divided by 100. Just knock off your, so it's 10 meters per second. Okay, so that's how fast he was falling. So last question, which of these equations gives Graham's height t seconds after he opened his parachute? Okay, so which of these formulas match? Let's have a look here. If I've got the time going across here, so there's the time. Use a different color to make it easier to see. So here we've got the time t. Let's try something. Let's try something that's nice and easy to see. What about at 0? At time 0, the height should be 1,000. Okay, so let's try this case. So if time equals 0, what just happens here? We get 100 times time plus 900. That will give us, that'll be 0, that's 900. Does that work? Is that what we should get? Nope, that one's not working. Okay, what about B? This one here. Let's make some room here. So if time was 0, so 10 times 0 plus 1,000, that will give us 1,000. So that's a possibility. Okay, it might work. Let's try C. Just move over here. 10 times 0 plus H equals 1,000. What does that give us? 10 zeros is 0. H equals 1,000. Okay, it also might work. So now we need to work out of these two, which is the one that's actually working. So let's try a different one. Let's try at t equals 80. What should the answer be? 200. So let's keep trying these ones. What about if t equals 80? So let's do this one. So h equals 10 times 80 plus 1,000. So what's 10 times 80? That's 800 plus 1,000. So that's going to give us 1,800. That's not looking like it's working, is it? So let's just test our last one to make sure we've got it. If t equals 80, what do we have? Our formula is 10 times 80 plus h equals 1,000. So 10 times 80 is 800 plus h equals 1,000. That means h is equal to 200. I believe that's what we wanted. Yep. So this one works. And that means the answer is C. That's the formula that works.